In this lesson, we are looking at intersection of lines. Across the higher course, there will be quite a few occasions where the technique of solving a pair of equations, straight line equations, will be necessary. In the current topic that we're looking at, we're having to find, sometimes you might be asked, the intersection between an altitude and a median, for example. So basically, if you're given a pair of lines that cross over each other, then we're trying to find the x and y value which works for both equations. Okay, so this is where you've met this before when we were doing solving simultaneous equations. That's a technique that we can use to solve this. So for example, if you were asked to find the point of intersection of the lines with these equations, 3y equals x plus 15 and y equals x minus 3. In the first instance, just because of the technique that you've used in the past, I'd be saying that we should it's really recommended that you rearrange your equation to have your x's and y's on the same side. So for example, this first one, 3y equals x plus 15, that can be rearranged as negative x plus 3y equals 15. The other one, y equals x minus 3, again, rearrange it and it becomes negative x plus y equals negative 3. So putting these two equations together, and we're using the elimination method. That means we're getting rid of either the x's or the y's. So here, because the x's have both got the same signs, then the technique that you should use is to subtract. It's also a good technique to number your equations and explain by stating at the side whether you're adding or subtracting your equations. That's good communication to do that. So here, subtracting leads us, you can see at the side here I've written, if we're doing negative x, take away negative x, that's the same thing as negative x plus x, which of course is 0. So we've eliminated the x's by subtracting these equations. So we get 2y equals 18, that gives us y equals 9, and of course once you've worked out the y value, you then need to get the x value. You do that by subbing back into one of the equations, it doesn't matter which. So if we sub back into equation 2, for example, you get negative x plus 9 equals negative 3. Rearranging that becomes negative x equals negative 12. And of course, we need to get it to x equals. So you can either think about multiplying or dividing through by minus 1 to do that. So now that we've worked out an x and y value, putting those together, because we're specifically asked about the point of intersection, make sure you write it as coordinates rather than just leaving x equals 12 and y equals 9 as you're working. So that's just revisiting the technique that you've met before. And again, at National 5, you could sometimes be asked to find the intersection between two lines. So the first example in our notes that we'll look at just in a little minute, we'll go back over that technique again. But more specifically at higher level, you've met names of lines that we need you to be aware of. So there have been 3 different types of lines that we've looked at. We've looked at medians, right? And the median, remember, goes from a point to the opposite side, and it's the middle that we're looking at. So that one involves the midpoint when we're doing that. Then there is the altitude, and that was in lesson 8 that we looked at that. And an altitude, another word for that is a perpendicular height. So that's the one that we use the perpendicular property in. And the one that we looked at in last lesson was perpendicular bisector, which uses both midpoint and the perpendicular property. So knowing what these 3 types of lines are and an awareness of them will help us as we go forward. So in your higher notes, the first question here is, how do you find, or you're asked to find the point of intersection of these lines. And as we've already said, the first part of this, right, would be looking for you to rearrange right, both of these. So we would be looking for you to rearrange the first equation there. We would be writing 2x and your minus y on the one side, and the plus 11 we take to the other side, it becomes negative 11. So we're rewriting it. And second equation, right, rewriting it becomes x plus 2y, and that would be equal to positive 7. And then I would be looking to number these equations. So numbering, right, this would be equation 1, this would be equation 2. Now in this instance, neither the x's nor the y's are matching up in terms of their numbers. So recall that that is something that we need to be able to do. So we either have to get the numbers in front of the x to be the same, or the numbers in front of the y term to be the same. So I'm going to suggest, because we've got a minus and a plus going on with the y term, that actually if we had a 2 there, it makes it easier. So I'm going to multiply by 2, which means that what we're then required to do, I'm just going to leave a line and a space rather, so that I'm going to rewrite my equation. So I've got 4x, right, so we're going to have 4x minus 2y equals minus 22. So multiplying everything by 2. So I'm going to refer to that as equation 3 at this point. The second equation, I can just leave it as it is. So I'm going to have, right, that equation written as x, right, plus 2y equals 7. So I'm still going to call that 2. And right, from at this point, right, we're then able to see if we add these equations. So equation 3 plus equation 2. So we've got equation 3 plus equation 2, and we're going to have, that would give us 5x. The y terms will cancel, and we've got minus 22 plus 7, which is minus 15. Dividing, of course, by 5 gets me to x equals minus 3. Of course, once I've worked out the x, I then do need to sub that in to work out my y value. So sub x equals minus 3 into whatever equation, either 1 or 2. Here I'm going to sub it into equation 2. So that would make me have negative 3 plus 2y equals 7. Rearranging that would mean that I would have 2y equals 10. So y would be equal to 5. Putting that together means that I can write down my point of intersection is therefore going to be the point negative 3, 5. So that's just another example of just solving a pair of equations. It's the next question that is more of the style of a higher question that you're likely to come across. So you've been given a triangle here, PQR, and we've been asked to, part A asks you to get the equation of the altitude QS, then part B asks you to find the equation of the median RT, and then part C says hence. The word hence usually means what you've found before from part A and B. Use that to help you find the coordinates of the point M. So this is where a bit of knowledge of knowing what it means by an altitude, knowing what it means by a median is essential. Right? If you can't, you won't be able to get started on the question if you haven't learned the definition of these terms. My advice, although that diagram is there, when you do your work in, break it down and just think about each part as we come to it. So in the first instance, we were being asked to work out the altitude QS. So to do that, we need to think, right, an altitude. So if you were doing this type of question, you should really be thinking to yourself, oh, altitude, that's the one that's to do with the perpendicular, and actually marking in your information. So you would be marking in the perpendicular section at the bottom there. So having done that, then thinking to yourself, there's 3 steps to get there. First thing I need to be able to do is work out the gradient of PR, and that's this bottom line. That's going to help me get the gradient of QS. So what I'd be doing for this, right, and again I would be labelling my points x1, y1, x2, y2. I would have them written down because it's P and R, and you'll notice the diagram I've got drawn here has just got the altitude in it. It doesn't have any of the other line information or any points that we need. And just a reminder that this is not the midpoint, right? Altitude is to do with the perpendicular work. So when you're writing down your working for this, you're going to be working out the gradient. So letter M for gradient, PR subscript, because they're the 2 points that I'm using, and it's going to be y2, which is -3, take away y1, and your x2, which is 2 minus the x1, which is 8. Okay, so that does give me -6 on the top over -6, so -6 over -6, that's going to give me a gradient for PR of +1. And that's my first step, that's the first bit, and if I was doing an exam, if this was an exam question, that's what would earn me the first mark. The second step, once I've got that gradient, I'm ultimately looking to get the gradient of the altitude. So, and remember that's using the perpendicular property. So because we know the gradient of PR is 1, that tells us that the gradient of our altitude, QS, will be -1. Right? Using the property of them, the perpendicular property, which is if we multiplied them together. Right? So remember that M gradient of PR times by the gradient of QS, because they're perpendicular to each other, we need it to be equal to -1. So step 3, putting all that information together to get the equation of the altitude. You're using your point. It's always a good idea to write a little statement that says I'm working out the gradient of the altitude, and I need the point that I'm using. This will be my A and my B, and I'm going to be using the equation y minus b equals mx minus a. So subbing into that, I'm going to have y minus 6 equals -1 bracket x minus -1, which is going to be y minus 6 equals -1 times x plus 1, which means I'm doing y minus 6 equals -x minus 1, and then tidying everything up. Now normally when we tidy this up, so +6 with that -5 would mean +5, and I would usually say to you it's okay to then leave your answer there. However, thinking ahead with this type of question, because we know we're going to have to find the point of intersection, I would strongly recommend that you rewrite this so that you've got your x's and the y term on the one side, so that you get x plus y equals 5 as your final answer, because you know you're going to need the equation in that form for part C. So part B, that's part A, that's the altitude. Part B is the median. Now again, I've drawn out the triangle here, and I've drawn in the median RT. So what's special about a median? What do we know about a median? Well, we know that this point T, median meaning middle, right? That means I should put 2 little dashes in there. What I don't put in is anything to do with perpendicular lines, no little square corners or anything, right? That's not the case here. So starting with this, the first thing we need to be able to do is work out the midpoint. And when we're doing the midpoint, again, the little formula and marking in that this is x1, y1, x2, y2, and your midpoint, so the coordinates of that point T that we're looking for, you are adding together, so you're 8 plus -1, right, all over 2, and your 3 add 6 over 2. So actually what happens is we get fractions here. So we've got 7 over 2 and 9 over 2. So that's our midpoint. Now, to find the equation of this line, as well as working out the midpoint, I now need to get the gradient of this line. So I'm going to be using the points R and T to do that. So our second step is gradient of RT. So our coordinates of our point T that we've just worked out were 7 over 2 and 9 over 2. So gradient of RT, and again you're doing x1, y1, x2, y2. If you have them written down, it's easy to see in front of you. Now this is going to look quite a wee bit clunky when we do this because we've got fractions over fractions. So y2, 9 over 2, take away negative 3 over 7 over 2, take away 2. So on the top there, what we will end up with, that becomes 9 over 2, and a take away negative 3 is going to become plus 3, but I'm going to write the 3 as 6 over 2 so that it's in halves. And then on the bottom likewise, so 7 over 2 minus the whole number 2, I'm going to say that's 4 halves. So what we end up with, right, on the top of our fraction there, we will have 15 over 2 on the top, and that has been divided by, on the bottom, 3 over 2. And if you remember anything about fractions, that means that we're doing change divide to times and flip it. And then I'm looking to be able to do some cancelling with the 2's, and that will, and also cancel between the 3 and the 15, which means that our final gradient that we're looking for is actually 5. So quite a tricky one that, because it involved the fractions, but it's not beyond you. You've got all the skills there, it's just a matter of taking your time to do that. So now that we've got that done, we want our equation of RT through. Write the statement, say which point you've chosen. You could use the point T. I'm going to suggest that you use the point R. That's going to be my AB, because I'm going to be subbing in to y minus b equals mx minus a. So I'm going to have y minus minus 3 equals 5x minus 2. So that's going to become y plus 3 equals 5x minus 10. And again, tidying up the numbers, so we get y equals 5x, we get minus 13. So when we've done this, remember that our aim in part C is to put together the altitude and the median. So I really would prefer that you rewrite this so that you then have the x's and the y's on one side. So we get minus 5x plus y equals minus 13, and that's our answer for the equation of the median. So putting together our answers for A and B, you can see our altitude was x plus y equals 5, and the median that we've just found is minus 5x plus y equals minus 13. And when we solve them together, we're looking to find this point M, which is the intersection point. So again, at this point, you will take your answers from part A and B, and it's also a good idea to number these equations. Looking at this here, we can see the y terms are both the same sign, right? They're both positive, but I can solve this simply by saying, right, I'm going to subtract. If they're the same signs, then you subtract your equation. So I'm going to do equation 1 minus equation 2. So that means I'm doing 1x take away negative 5x, so that does become positive 6x. The y's are eliminated. 5 take away negative 13 becomes 8. 5 add 13, which is 18. And then dividing by 6 means that x will be equal to 3. And the easiest one to sub into here is equation 1. So sub in equation 1, you're going to have 3 plus y equals 5 means that y would need to be equal to 2. So our final statement at the end, right, of all this is that our point of intersection M has got coordinates 3, 4.